So I think I'm on page 4. So for f prime of a, we do have two definitions. And I did not get the chance to present those definitions to you last time. So in case, for example, if we are asked to find f prime of a, then I said, find f prime of x, and then just say, okay, fine. If f prime of x is this, then f prime of a will be 2 over a plus 2, everything squared. In case the question was asking f prime of a. That's all I was saying. If it doesn't, you don't have to do this. It's good enough, f prime of x. But now, since we're here, let's talk about the two definitions for f prime of a. One of them is identical with the previous one. Limit as h approaches 0 from f of a plus h minus f of a over h. What is this? Nothing. I replaced this by x. I'm sorry, I replaced x by a. It's the same thing, same definition. But there is another one, and you can ask, why a second one? Who cares? Well, to be honest, for some functions, f prime is easier to determine in this way. But for other functions, it's easier to determine it like this. Limit as x approaches a from f of x minus f of a divided by x minus a. Same thing. y2 minus y1 over x2 minus x1 when x approaches a. It's exactly the same definition. It looks differently, and for some functions, this will be easier to simplify than this one. That's all there is. But I didn't get the chance to present these two to you last time. So that's why I said, okay, if the problem says find f prime of a, then just find f prime of x. Any questions? Is there anything else?
The question also says to find the domain of the function and the domain of the derivative.
Awesome. Yes. So can anyone give us a domain for the function? And then the domain for the derivative. So this is
the function is negative infinity to negative 2.
Union
exclusive. Yep.
negative 2 to infinity. Awesome. And this is the same. If you look at the derivative, exactly the same domain.
Well, the derivatives usually, is that a trend that they'll be the
Nope.
same?
No, very good question. Awesome, awesome, awesome. Yes, okay. So let's take a look at a couple of functions now. Very good question, thank you. So let's say we have the square root of x. This is a very important function, and we have to memorize the answer. So the answer will be a super important concept, or definition, or rule, whatever you want to call it. Good. So we want to find f prime for this function, and first let's find its domain. Can anyone give us a domain of this function? We discussed it last week. Yes, I'm ready.
0 to infinity?
Yes, of course. Remember, we can only take the square root from positive or 0. Good. So can anyone dictate the first step for finding the derivative using the definition? We don't have anything else yet. Can anyone get us started?
Square root of x plus h.
That's not the definition. That's not the definition of the derivative, please. The derivative consists of two concepts put together. Yes.
As h approaches 0.
I completely agree.
Of the function of x minus h.
It has to be plus.
Sorry. Okay,
minus,
sorry, x plus h. I'm sorry.
No worries.
Minus square root of x.
Perfect. Of course, this is 0 over 0. There is no discussion because it's f of x minus f of x over 0. So now what do? We had an example like this, way more complicated, that you dictated to me last week. What do we do for this function? In this case, I meant to say. Anyone?
Conjugate?
Of course, absolutely, because we are talking about irrational quantities. Awesome. So I'm assuming you have x plus x, the square root of x plus h, plus the square root of x, x plus h, plus the square root of x. Awesome. Can anyone give us the numerator? Do not drop the limit operator, please. Can anyone give us the numerator? We had an example like this in the concept check, the puzzles. Anyone? There is no need to FOIL. It's a minus b, a plus b, which is a squared minus b squared. It's a waste of time to FOIL. It's correct, but it's a waste of time. Sorry, somebody wanted to say something.
Never mind. I don't think it's correct.
It's okay. Let's take a look.
H.
I have to show everyone how we get that.
Okay, it's x plus h minus x.
Good. So these two go away. Do not simplify again here, please. In this case, we have to write it again. Do not drop the limit operator. We did not apply it yet. So the first step happened. All terms without h are gone. Does the second step happen?
Second step is going to be removing
Excellent.
or simplifying the h.
Perfect. Awesome. Now the third step. Now we apply the limit operator and it disappears. What is the final answer? The numerator is
1.
yes, and the denominator is
Root.
say it a little bit louder. You probably said it, but I didn't hear it. Do I need a hearing aid? I don't hear anything.
The square root of x plus h plus square root of x.
We are applying the limit at this point.
Would it be square root of x plus square root of x?
And how much is an apple plus an apple?
Square root of 2x?
How much is an apple plus an apple?
The 2 times the square root of x.
That's it. Awesome. So from now on, we have to carve in stone that the square root of x prime is, again, how much? What did we get? Can anyone say it?
1/2 x to the negative 1/2.
1/2 the square root of x. Good. So now we found the domain for the original function. Now let's find the domain for the derivative, because that's how we started. I needed to do this anyway, so this was my next step, regardless. But we needed to, the initial discussion was, will the domain be the same? If the function has domain 0 to infinity, will the derivative have the same domain? That was our question. What do you think? Can anyone give us the domain for this function? And remember, if you don't understand something, you must stop me.
The domain is 0 to infinity, 0 inclusive.
But can I include 0?
Can you include 0? Oh, no, you can't, because 0 times 2 is 0, right?
Because the
Yes, and
denominator.
it's in the denominator. Yeah.
Exactly. So no, we cannot always say it can or cannot happen. We don't know. We have to look at the function and we have to look at the derivative. Any questions on this?
I have a question about.
Sure. Yes, go ahead.
It's about finding limits. When you find a limit, is that limit automatically a horizontal asymptote, or is the limit different from the horizontal asymptote?
Horizontal asymptotes are determined only when x approaches infinity.
Okay.
We are talking about h. And this is a different concept. This is the concept of the derivative. So this is the limit of the difference quotient, which gives us the tangent. It does not give us the limits at infinity. It gives us the slope of the tangent line at every point where the original function is differentiable. It has nothing to do with horizontal asymptotes or vertical asymptotes. This is a function that gives us the slope of the tangent line, here, 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 whatever, on the graph at any point where this exists or the function is differentiable. Very good question. Anyone else had a question, I think?
I have a question
Yes.
about when it's like the when the answer is a horizontal asymptote at infinity only. Like, what type of functions did you mention that would only be for?
When we use the sign of the derivative. So when we use the sign of the derivative, then and it depends what we get. So, but you are not connecting into this because this is okay. Okay. So you're saying basically, how do I know when it's only at one end and when it's at both ends? Is that the question?
Yeah, like when when you basically, the example for the question I'm asking is like for the homework. I think the number 47, I don't know when we did that. Actually, no, it was one of the problems that we did, but it's kind of like when it's a horizontal asymptote, full stop, and then when you mentioned that there's an exception. So
the exceptions are, you have to be careful when the function is not a pure rational function. If the limit is of a function that is a pure rational function, then the horizontal asymptote is at both ends. But if it's not a pure rational function, then we don't know till we look at both ends. So we cannot conclude. So, for example, we just looked at the, I'm just changing the time for the first discussion that I would like to look at. So, to answer your question, I'm on page 5. So if you have the limit as x approaches infinity from x cubed plus 1 over 3x cubed plus 2, this is a rational function. So whatever you get, if you get a number, only a number, which you will, which is 1/3, so this is a horizontal asymptote, period. So y equals 1/3 is a horizontal asymptote at both ends. But if you have the limit as x approaches infinity and you have e to the x minus 1 over, let's say, the square root of x squared plus 1, then it depends. Okay, so I'm just making...
that's what I mean.
Yeah, so this, what I mean to say here is that this function is not what is called a pure, like this one, a polynomial over a polynomial. If it's not a polynomial over a polynomial, like this one, it's not polynomial, it's not polynomial. This is not a pure rational function. It's a combination of exponential with the radical or the square root, and in addition this a ratio. So this is not a pure rational function. But a pure one will have the same thing at both ends, but this one will not.
Okay, thank you.
Is that better?
Yep.
Okay. So one suggestion I have for you, do not answer the discussion before we talk about it. So before I say, I see 1, 2, 3 already, you went ahead instead of paying attention, which is okay, fine. But I will not take the answers if you start before I say we are ready for the discussion, please. So I didn't say it, it's my fault. I changed the time because I haven't finished and I didn't get to it. So please don't do this again. Sorry, I will not put the time in there, and I will not let it be open from now on, so we avoid this situation.